All right, so chapter 4, we're going to learn about a new type of function. So we've learned about linear functions, and then in chapter 3, we looked at quadratic functions, and now we're going to look at exponential functions. So if you remember, a linear function changes at a constant rate. Okay? You can think of that as using addition or subtraction to get from one y value to the next y value. Exponential functions change at a constant percent rate. Okay, and so that percent that we're changing by means that we're using multiplication or division there. All right, so let's take a look at an exponential function. So I have a growth and a decay here we can take a look at. So after graduation from college, you will probably be looking for a job. Suppose you are offered a job with a starting salary of $40,000 per year. To strengthen the offer, the company promises annual raises of 6% per year for at least the first 4 years after you are hired. Compute your salary for the first 4 years. All right, so year 0, when you start there, you'll be making $40,000. Then you're going to get a 6% raise. So we'll do 40,000 times, and now that's 6%. If we change that to a decimal, is 0.06. Okay, so one of the things you're going to need to be comfortable with in this chapter is switching between these percents and these decimals. So take that 40,000 and I'm going to multiply that times 0.06. So I'm going to get a raise of $2,400 that first year, which means my new salary, I add that 40,000 to that, is going to be $42,400. All right, and then the following year, I'm going to get another 6% raise, and it's not going to be $2,400, it's going to be more than that because we're going to take 6% of my new salary. So I still have that $42,400 in there, so I'll do times 0.06, which means I'm going to get a raise of $2,544. So I'll add that to my old amount. Now my salary for that next year is $44,944. Right, so that's not bad. After 2 years there, it looks like I'm getting close to a $5,000 increase in my salary. I like that. My third year, I'm going to get another 6% raise, and that's 6% of this. So that gives me, oh dear, $2,696 more and 64 cents. So I'll add that in. That gives me $47,640.64. And then one more after my fourth year, because they did promise me 4 years of raises. So that's going to add $2,858.44. We'll add that to our old amount. Okay, that gives us $50,499.08. Okay, so within 4 years, I went from a salary of $40,000 to a salary of $50,000. And then down below, you can actually see what that would look like. That's your salaries there if you were to continue getting a 6% raise every year. Okay. All right, and then let's look at an example of exponential decay. So the half-life of a drug is the amount of time it takes for 50% of that drug to be removed from your body. So suppose you're injected with 500 milligrams of a drug that has a half-life of 3 hours. So every 3 hours, it's going to decrease by half. How much of the drug will be in your bloodstream after 24 hours? Right, so we started out with 500, and we're going to cut that amount in half. So half of 500 is 250. That's how much we'll subtract off, which leaves us with 250. After 6 hours, this amount is going to be cut in half again. So 250 divided by 2 gives me 125. If I subtract 125 from that 250, I get 125. So these numbers are going to stay the same because what we are doing is we are taking 50% off. Okay, which means 50% remains. If it had been 40% off, then it would have been 60% remains, and then these two numbers would have been different. Okay, so they only work out to be the same if you're doing a half-life. Right, 125 divided by 2 gives us 62.5. And we'll divide by 2 again. That gives me 31.25. So this means that after 12 hours, so half of a day, if I took that 500 milligrams in the morning, 12 hours later, I'm going to be down to just 31 milligrams left in my bloodstream. Divide that by 2. So that gives us about 15.63. Okay, we'll divide that by 2 again to see how much is left after 18 hours. So that's 7.81 milligrams. Divide that by 2 again, so we're down to 3.91. And after 24 hours, 24 hours after we took that 500 milligram injection of that drug, we're down to 1.95 milligrams left in the bloodstream. And picture-wise, this graph, instead of this one that was growing, this one's going to come down and swoop at an angle like that. All right, so when you come back to the next video, we're going to define what exactly an exponential function looks like.